Today we're going to start a short unit on motion. We've done some stuff on motion. This is just going to, I'm going to try and tie it together a little bit better because we did some here and some there, and I want you to have it all at once. So the three things that you have to keep straight are the idea of the position, velocity, which is the rate of change of position, and acceleration, which is the rate of change of velocity. Now, this says motion along the x-axis. We'll say sometimes on the AP exam they'll do, motion along the y-axis. It doesn't really matter. It just needs to be along some line, okay? And we'll only do motion along horizontal or vertical lines. We'll never do anything where the line is moving at an angle or something. That gets a little more complicated. So, if x of t represents the position of a particle along the x-axis at any time t, then the following statements are true. Initially means when t is equal to 0. At the origin means when x of t is equal to 0, which may or may not be at time 0. Okay? At rest means the velocity is equal to 0. We're going to stop there for just a second. When they say at rest, they don't mean that it's just sitting there for a long period of time. The rest period can be instantaneous, right? It doesn't have to pause for any perceivable length of time. It just has to have a velocity of 0 for that instant, okay? If the velocity of the particle is positive, which way is the particle going to be moving?
To the right.
To the right. If the velocity of the particle is negative, then the particle's moving to the left. So to find the average value or the average velocity over a time interval, divide the change in what by the change in time?
Position.
Yeah, it's position. Notice that this is also the average rate of change in position. It's the same thing, right? The average rate of change in position, well, since the rate of change in position is velocity, this is average velocity. The instantaneous velocity is the velocity at a single moment or an instant in time. I like that. I borrowed this from the College Board, and I liked that they had an exclamation point at the end of instant. It just kind of tickled me. All right, if the acceleration of the particle is positive, then what is increasing?
Velocity.
The velocity is increasing. And then if this acceleration of the particle is negative, then the velocity is decreasing. We will, I don't think it's today, I think it may be Monday, we'll talk about the difference between velocity and speed and how it applies to calculus problems. All right, in order for a particle to change direction, what has to change signs?
Velocity.
The velocity has to change signs. And I'm going to point out that students sometimes take that a little too far. What they do is they say if the velocity is 0, the particle's going to change directions. But I think we've talked about it in this class before. If you pull up to a stop sign, can't you continue going down the same road? You don't have to suddenly throw it in reverse then. Okay? All right. So then, one way to determine total distance traveled over a time interval is to find the sum of the absolute values of the differences in position between all resting points. Right? So it's the particle is, say, moving to the right, and then it switches and moves to the left. We can take the differences in each of those, and it's be the absolute values of the differences. So if the position of a particle is given by this really, really, really horrible looking function, find the total distance traveled from time 0 to time 6. So what we can do is we can go, okay, let's find the resting points. So we'll find v of t, which is going to be t squared minus 2t minus 3. And we'll set that equal to 0 to find the resting points. So that's going to be, what, t minus 3 times t plus 1. So t is 3, or t is negative 1. Well, negative 1's outside of our interval, so we'll ignore that. So what we need to do is find, well, what is x at 3 minus x at 0? And we'll take the absolute value of that plus the absolute value of x of 6 minus x of 3. You see what we're doing there? We're finding how far did it travel between those resting points. So x of 3, let's see if I can do that in my head. That's going to be 9 minus 9 is 0. Minus 9 is negative 9. Plus 4 is negative 5. And at 0, that's at 4. So the absolute value there is 9. Plus x of 6, that's 108 minus 36 is 72 minus 9 is 63 plus 4 is 67? I'm hopeful that someone's actually checking me on that. So is it 72? So the total distance traveled would be 81. Now I want you to notice something here. X of 3 minus x of 0, wouldn't that x of 3 minus x of 0, isn't that the same as the integral from 0 to 3 of v of t dt? Because x is going to be the antiderivative of that velocity function.
You can't see your screen.
Oh, have I had my screen off this entire time?
Potentially. You're just filling in blanks so it was easy.
All right, well, I'm going to check to see if I actually calculated that one part right. So 6 to the 3rd divided by 3 minus 36 minus 18 plus 4. Yeah, well, I had the 2 part right. I don't know how I got 67. I'm not even going to try to recreate it. This is actually 22. That's so far off as to be hilarious. So this is 36. All right, we'll talk more about integrals with this a bit later. But that's it for today's lesson. A little mini lesson just to remind you of some things. And we'll talk more about this, I think, on Tuesday. I think that's when we talk about that again. Yes, we'll talk about that on Tuesday. Okay, so we only have at this point, if I remember correctly, 2 units left. And then we'll be reviewing for the AP exam. Those 2 units will be this one on motion, which is tying up all the stuff on motion. And then the other part will be some bits and pieces of things that didn't fit anywhere else nicely. And then after that, we'll be starting to review.